Question show time. Your questions, my answers, wherever you are, anywhere on my channel. If a question pops into your brain, just write it down. I'll gather them up and I will answer them here. Now, we've got another guest answerer this week, so make sure you stick around right to the very end. All right, let's get into it. Billy Boyuk. Hey Fraser, is it possible for a spacecraft or any object to come to a dead stop in space? If so, how could this be determined from the object's point of view? What would the Milky Way look like if this were possible? If we came to a dead stop relative to the Earth, would we see the Earth and the other planets whiz by? The problem is there's no such thing as a stop in space. Everything is relative. You feel like you're not moving because you're standing on the Earth and your house isn't moving around you and the trees aren't whizzing by. You're standing. But when you're in a car, then you're moving and you think that everything is standing still. But the reality is, of course, you're standing on the Earth and it is turning 1,000 kilometers per hour. So you're moving in a big circle at 1,000 kilometers per hour. The Earth is going around the sun at 30 kilometers per second. So you're moving at 30 kilometers per second, which is very, very fast. The solar system is orbiting around the Milky Way. The Milky Way is orbiting around the local group. The local group is being part of the Virgo supercluster. So everything is always moving. And so whenever you say, if you came to a complete stop, it would be relative to something. Yeah, if you were able to cancel out the 30 kilometers per second that the Earth is moving and you were out in space, as the Earth swung past you, you would see the Earth whip past you at 30 kilometers a second. If you were closer into the solar system, you could see Venus go past you and Mercury, right? And so there's no place that you can go in the universe where you are effectively stopped. There's no zero. You will always be moving compared to something. You may be moving towards things, you may be moving away from things, you may be moving the same speed as things, and so they appear to be stopped to you, but there's nowhere you can go. Freesertron. I wonder what the physical limits of optical telescopes is. Could we get really detailed pictures of exoplanets? There's no physical limit for a telescope. You could have a telescope here on Earth, like probably the largest physical limit is about 100 meters across. This was a plan for the overwhelmingly large telescope, but it was canceled because it was going to be too expensive, and so they're building the extremely large telescope, which is going to be 39 meters. But 100 meters is sort of the physical limit of what you could probably build here on Earth. And the limit is the force of gravity. How the force of gravity is tugging down all of the support structures of your mirrors when you're here on Earth. Now, if you went to the moon, where gravity is only, 18%, 15% of the force of gravity here on Earth, then you could build a telescope that is 6 times bigger. If you put it just out in space, then there's no practical limit really on how big of a telescope you could make, just really how well you can make sure that all of the parts of it are aligned to be able to gather the light together. Of course, if you made it, if you can't make it with a really high degree of precision, you can just make it bigger, and so it just gathers more light poorly. And you can imagine a telescope that is just monstrous. And if you got to one of those big telescopes, you would be able to start being able to image the surface features of other planets. The other possibility, of course, we've talked about this in previous shows, is if you could take a telescope out to about 1,000 astronomical units away from the sun, then you could use the gravity of the sun to act as a natural lens, and you could see almost directly houses on other planets, right? So there's and I forget the exact math to this. There's a calculator you can use, but you can just build the telescope bigger, and it allows you to see farther away at a higher level of detail. Flash Cobra 89. Once the sun expands in the distant future, won't Mars be in the perfect habitable zone to support liquid water? Is it possible the sun heats the planet up so that it can support an atmosphere? Yeah, as we mentioned in previous episodes, the sun is slowly heating up, and that's because helium is building up in the core, and that helium is making the sun give off more radiation. And over the next, say, 500 million to about 1 billion years, the temperature here on Earth is going to heat up to the point that the oceans boil, and there's really not going to be any life on the surface of the Earth. But that is going to be making places farther and farther into the solar system a little warmer. And you can imagine sometime right at the very end of the sun's life, when it bloats up as a red dwarf and consumes Mercury, consumes Venus, maybe consumes Earth, that's still a conversation that people are having, then it might get to a point where Mars is actually very warm. But the problem is that Mars is so dry. Whatever water, most of the water that Mars had a long time ago has all been driven off into space because it doesn't have a very thick atmosphere. So you wouldn't be able to you wouldn't really enjoy your time on Mars unless you could thicken the atmosphere, bring more water and try to beef up the atmosphere. And then, of course, the solar wind is still going to be grinding away at Mars, trying to blow that atmosphere out into space. So yes, maybe in 5 billion years, Mars would be a little more habitable. And so would the moons around Jupiter. Europa and Ganymede, they would all melt and be briefly in the habitable zone of the star. So that would be kind of cool. But the problem is that so far in the distance, we would have a really hard time thinking that we would still be here in 5 billion years from now. Epoch Singh. Saying that it's worthless, but what I am saying is that can we spend more time, energy, and money to build technology which can take us to our neighbor star in 20 to 25 years, or maybe earlier than 80 to 100 years? Thanks. This was the other complaint that I got on the Dragonfly episode that I mentioned, where I was trying to find the most realistic plan possible to send a probe to another star, where every part of it, from generating the laser to building, releasing the sail to building a magnetic sail, we're all at the very limits of what we think our future technology will be in the next few dozen years, next 100 years. And I got this a lot, which was like, yeah, but that's too long, right? 80 to 100 years, we should come up with something more clever and then do it in 20 to 25 years. In other words, we should be able to do this in a human lifetime. In other words, the people who start the work on this project should be able to see the spacecraft land. And that would be amazing. But right now, we just don't know of a way that we can. The reality is that traveling within the solar system is going to be straightforward. We will get better and better at it, and we will colonize a good chunk of the solar system. But sending spacecraft to other stars is going to be at the limits of our engineering capability for a long time into the future. And I know that sucks, because science fiction has ruined our brains. You watch Star Trek and they just get in their spaceship and they just engage the warp drive and they appear at their destination, or they go through the wormhole, or they go through the Stargate, or they engage the jump drive, or whatever, right? And the problem is that none of that stuff is real that we know of. None of that stuff works right now. And obviously, if someone comes up with a discovery down the road that makes those technologies possible, then we get to rewrite everything and come up with a way to travel to other stars more quickly. But until then, we have to get comfortable with the fact that we're going to be stuck here in the solar system for a long time. Andrew Stewart. Is it possible that there is a stellar mass black hole hiding just outside our solar system? I remember before the Planet 9 stuff became big, there was a story about a planet or a brown dwarf between us and Alpha Centauri, still connected to the solar system, but very far out. The smallest possible black hole is going to have many times the mass of our own sun, maybe 5 times the mass of the sun, 10 times the mass of the sun. It's going to have a lot of mass. So if there is a black hole that is near to our sun, it is the dominant gravitational object in our region. We are orbiting that black hole. It's not like it is just hanging out around in the outskirts of the solar system like a large planet might be, or even like a brown dwarf. But a lot of these theories, these ideas that there could be some other object out in the outer solar system, is to correspond with, there's this idea that some of the mass extinctions that have happened a long time ago could have been caused by, say, some brown dwarf, that it's in a really long orbit and it takes 10 million years to come in relatively close to the sun, and it messes with the Oort cloud and sends more comets down inward, and we experience more comets likely to smash into the Earth. But the evidence really seems to be that there aren't any large objects out there. Astronomers are just teasing out the influence of perhaps some object that is maybe even Earth-sized, that is causing some interaction with the other Kuiper Belt objects out there, and that is sort of where the thinking is going right now. But you never know. Now, one of the really interesting outputs from the Gaia mission was that it mapped out the movements and positions of all of the stars that are around us, and it showed us that, in fact, in the near future, within the next few tens of thousands of years, other stars are going to come actually quite close to the sun, within a couple of light years, which is enough to cause a disturbance to the Oort cloud. So it could very well be that in fact, as the stars are just moving around the Milky Way, they interact with each other and they cause these disruptions on a fairly regular basis. So that's the more likelihood than a black hole. Chem Hung. Is colonizing Mars just for scientists and the rich? Can a homeless dude have a chance too? I don't think the rich are going to want to go to Mars and live there. The problem, like if you're rich, then you're going to want to be able to have all of the good stuff like air that you can breathe and water that's outside and trees and animals and things like that. I think that the people who are going to want to go to Mars are the people who are choosing specifically to live in a place that's very, very difficult. So think about the kinds of people who go and live in the middle of the wilderness and they build their own house and they grow their own food and they homestead, right? Even though we now in our modern age, you can live in a city and you can have a car and you can have central heating, like there's something to that lifestyle that they enjoy, the challenge of it. And I think if you wonder if that's the kind of person that you are, then you can imagine like testing yourself. Go and try living without electricity for a day. Go and try growing all your own food for the year. Go and try reducing the waste that you use down to almost nothing to see, you can put these kinds of restrictions on yourself to test if that's the kind of challenge that you're up for. And to take it to the next level, try living in a place that's really inhospitable, like the middle of the desert, or in some high up on a mountain. And all of those places are going to be far easier to live on than Mars. So no, I don't think it's going to be for the rich. It's going to be for a very specific kind of person who really enjoys a really difficult challenge, and taking on that kind of a challenging existence is something that they find an enormous reward. I think we all have this kind of romantical notion about it, right? Like, oh, that'd be really cool to go and live on Mars, but see where you would be 500 days into it, 1,000 days into it, where day after day after day, you're spending most of your time just struggling to stay alive. And this is something that you've chosen. So no, I don't think it's going to be the rich. It's going to be the kind of people who are into this. Ready, set, PUBG. What about Voyager 3 in 2020, but with better technology, a bigger probe, and much more battery life? I've had a few people recommend, like, oh, why don't we do a Voyager 3? Because the Voyager spacecraft were so successful. And they really were, right? They gave us our first good look at Uranus and Neptune. They did a much better view of Jupiter and Saturn than the previous Pioneer spacecraft did. We got really just this amazing view of the entire solar system. But I don't think there's ever going to be a Voyager 3. The Voyagers were a flyby of the big objects in the solar system. And that work has been done. We've done the flyby. And a good example of this is like New Horizons, right? New Horizons flew past Pluto. It did the first ever flyby of Pluto, took a couple of pictures and moved on, and then it went to MU-69 and then took some more pictures and is moving on. The flyby work is done. Now it's time to send the orbiters, the landers, the rovers, and the sample return missions. So the next version, so instead of saying, oh, we should send another flyby to Jupiter, we've already sent an orbiter to Jupiter with the Galileo spacecraft. There's one there right now with the Juno spacecraft. The next step is a lander. Let's have a lander on Europa. Let's have a sample return. Bring a sample of Europa back to Earth. That's what the next, as we better understand this solar system, we focus in on these different worlds and try to learn as much about them as we can. All the big flybys are done. Now it's time to get down to the details. Iron Tusk 341. Working in a steel mill got me thinking, for artificial or simulated gravity, especially on worlds like Mars, the Moon, or Europa, where gravity is weaker, could we make platforms made from, say, cobalt, nickel, or alloy sheeting and have magnetic boots for, say, an iron, nickel, or cobalt atom, or magnetic alloy woven clothes or boots to wear on a magnet plate to simulate gravity? I see where you're going with this, and you're kind of like partly right, that when we're out floating in zero gravity, it would be probably useful to have some kind of magnetic boots so that you don't float around, that you can actually walk around your spacecraft. The spacecraft plating would be some metal, the boots would be magnetic, you'd be able to turn them on, turn them off, and be able to keep your feet on the ground. Now, it wouldn't be the same as walking around here on Earth, because the gravity is sort of pushing down on our bodies and helping us get friction as we move around. But you would probably learn how to work with it over time, and it would probably work really well. And it's obviously, you're all thinking of The Expanse right now. You can save the comment. They do a great job of it in The Expanse, and it's sort of their way to kind of not have to try and simulate people floating around all the time on their sets. And then I can imagine, if you had some kind of gravity, or not gravity, but like some kind of magnetic system that you're wearing that was pulling your body down towards the earth, then you would, that might help with some of the problems of your muscles as your muscles atrophy when you're in the lower gravity. And right now you have to exercise all the time, but maybe that would make things a little bit easier. But there are changes in microgravity that even exercise and being sort of held down outside of your body aren't going to help you with. There's problems with your vision, fluid redistributes around your body, and we still don't really know what the long-term consequences are. So really, to be completely safe over the long term, we're going to need some kind of artificial gravity, which is probably going to come from spinning. That people are going to either live in a spacecraft that's spinning all the time, or they're going to spend time every day in some module that spins them up, and they go on a spin cycle for a few hours, and then when they're done they come back out. And we still don't know what is the right amount. Do you have to be doing this all day long, or can you get by with just a couple of hours? More research needed. Magic Smoke FPV. Can you explain how the sun is so hard to get to again, please? I missed that one. It seems so strange to me. Sure. The Earth is going around the sun at a speed of 30 kilometers per second, right? And imagine like having a ball on a string and you're spinning the ball around on the string. What stops the ball from flying away is the string. What stops the ball or what keeps the ball held out taut is that angular momentum, right? That circular motion that you're doing. And so the same thing's happening with the Earth. And so the Earth is just going to go around and around and around and around the sun. And so are you. And so the only way for you to get to the sun is for you to cancel your velocity that's going around the sun, which is this 30 kilometers per second. And an average spacecraft, just to get to orbit, a rocket needs to go 8.6 kilometers per second to get into orbit around the Earth. To escape the Earth takes another couple of kilometers per second to get to Mars, etc. And that's much less than the 30 kilometers per second. I highly recommend you play a game called the Kerbal Space Program that'll teach you tons about how to orbit and how to launch rockets and how orbits work and how changing orbits and one of the greatest challenges in this game is to try and crash your spaceship into the sun. It's really hard. Cody's Lab. Considering that rocks periodically get blasted off the Earth and get spread around the solar system, I say that Mars is almost certainly contaminated with Earth life, even if it's not from us. Shout out to Cody's Lab for asking a question. Thanks, Cody. You're the kind of person who's going to want to live on Mars. So when you wonder what kind of people, Cody, that's the kind of person who wants to live on Mars. And he'll do it too, I'm sure of it. Anyway, the thinking is that over the long history of the Earth, large asteroids have smashed into both Earth and Mars and have excavated material that have gone into ballistic trajectories and even have gone into escape velocity. So some asteroid has smashed into the Earth and kicked up rocks and dinosaurs and trees into space, and they have floated around the solar system for millions of years. And we know that we have meteorites from Mars here on Earth, so we know that these rocks can move from world to world. And we also know that, in fact, inside these rocks, as they come through the atmosphere, it can stay cool enough for life to be able to survive. And so this is the idea of panspermia, that space rocks are moving from world to world on Earth by asteroid collisions. And so if we ever do find life on Mars, the first question that we're going to want to answer is, are we related? Is the life on Earth somehow related to the life on Mars? And if so, when did we split? Because that'll tell us when that impact event must have happened here on Earth. Did the life start on Mars and then got to Earth? Did the life start on Earth and get to Mars? These are big questions. If we find life on Europa or Enceladus, is it connected that way too? We have to find out. We have to go to Mars and we have to look for life and try to find out if we're related. And if we're not, that's just as interesting because it tells us that life can appear twice just in our solar system, which means that life must be more common across the universe. Roger Wilco. Why not try to seed life on all or most of the planets? By the time it takes them to evolve enough sentience to build spaceships and take us over, humans will be long gone anyway. I think if you have this long view of what's going to happen in the solar system, I think that over time we will expand out into space and we will start to develop the kinds of technologies that allow us to live just at least in the zero gravity with large rotating space stations. You can imagine this really, really far future where humanity has been living in space itself for thousands of years, tens of thousands of years, hundreds of thousands of years, and you'll have different groups, and evolution may change people on Mars, and that really does feel like a backup plan for humanity, that we are throughout the entire solar system, that no one event can take us out. Even a black hole moving through the solar system would cause a lot of disruption, but maybe we would be able to handle that. So I have a lot of hope. If we can get past, if we can make that first step out into space and start to live in space, then our chances of being able to survive for the long term go way, way up, because there's just no one event that can take us out. So that's the backup plan, and I am definitely for it. Just not necessarily Mars, but out in space is good. All right, I've got a special guest question from, well, I'll let Christian Reddy from Launch Pad Astronomy get into it. He actually incorporates a question right into his answer. It's a little bit longer, but he did a great job of answering the question. So thanks, Christian. I'm going to put a link to Christian's website, Launch Pad Astronomy, and just sort of interesting insider baseball here. If you go all the way back to the beginning of the Guide to Space, the first episode that we have is called "Why is Pluto Not a Planet?" And Christian Reddy did that video like 5 years ago or 6 years ago. So it's great to still have him out there and involved. And thank you for making that first video for me, Christian. And thanks for jumping in and answering this question. Go check out his channel, subscribe. You won't be sorry. All right, take it away.
Thanks, Fraser, for handing me this really interesting question. Yara Papaja asks, are binary planet systems possible? Is there a reason why two planets couldn't orbit each other while together orbiting a star? If so, how much would our moon have to change for the Earth and moon to be considered a binary planet system? Well, that's a really interesting question, because Isaac Newton showed us that gravity is simply a force between any two masses separated at some distance. So when you have the moon going around the Earth, that's not technically true. Instead, what we have are the Earth and the moon each orbiting a center of mass. This center of mass is kind of like a balance point between the two bodies. An easy way to imagine this is to remember the good old days when you would ride along the seesaw with a buddy. If you and your friend were roughly the same weight, you would sit at roughly equal distance from the center. But if your friend got off and a big kid came along, well, then the big kid has to move closer to the center of mass. This center of mass has another name. It's called the barycenter. So when we talk about a moon orbiting a planet, what we really are talking about are the moon and the planet both orbiting the barycenter. Now, it turns out that we do have a binary planet system right here in our solar system. And I'm talking about Pluto and Charon. Okay, Pluto is a dwarf planet, and Charon is officially classified as a moon of Pluto, but the barycenter lies outside of Pluto's surface. It's reasonable to think of these two as not so much a dwarf planet and its moon, but rather as a binary dwarf planet system. Okay, so what about the Earth and the moon? Well, in our case, the Earth's mass is so much greater than the moon's that the barycenter is actually inside planet Earth. In fact, it's about 1,700 kilometers below the surface. Now, in order to turn the Earth and Moon into a proper binary planet system, Newton tells us that we can do one of three things. The first is we can reduce the mass of the Earth. Unfortunately, this would require some huge asteroid to come and smash off a huge chunk of the Earth's surface and mantle, and that would be bad. So let's instead increase the mass of the moon. But we can't just increase it a little bit. We'd have to increase it by nearly 3 times. So we would really have to add a lot of mass to the moon, and that would wreak havoc with the tides here on Earth. But another way to move the barycenter outside of the Earth is to push the moon away from Earth. And believe it or not, the moon is in fact inching away from Earth. And when I say inching away from Earth, I mean the moon is literally moving about 1.5 inches farther away from the Earth every year. So in about 100 million years' time, give or take a few million, the Earth-Moon system will be far enough apart that the barycenter will be in space between the Earth and the Moon, and the Earth-Moon system will be a binary planet system orbiting our Sun. Thank you, Yerapapaja, for that great question, and I hope to see all of you over at Launch Pad Astronomy. Back to you, Fraser.
All right, thanks, Christian. Again, make sure you go and check out his channel, Launch Pad Astronomy, here on YouTube, and I hope he'll come back and answer another question for us sometime. All right, we'll see you all next week.